Okay, so for our next question, what we want to do is graph the system of inequalities. And we are going to start off with this one here. And this is a nice one because it's in the form of y equals mx plus b. I can identify the y-intercept at 7. And my slope is negative 2 over 1. That tells me to go down 2 and over 1 to the right. Down 2 over 1 right. Down 2 over 1 right. And this is or equal to, so we're going to include this boundary line here. Now, I like testing the point 0, 0 to see what side to shade on, so I'm going to plug in 0, 0 and see if it's true or false. Plug in 0, 0, I have 0 is less than or equal to minus 2 times 0 plus 7. This gives me 0 is less than 7. That's true. That tells me I'm going to want to shade on the 0, 0 side. We're also going to graph x is greater than or equal to 3. I have to figure out where is x actually equal to 3. Right here. Straight up and down. Or is it greater than 3? Well, that would be like 4, 5, 6, everything right here. Remember, we only want to shade where they both overlap. So I'm going to shade only in this region here where the two overlap each other. In this area, this is where both of the inequalities are true. All right, for our next one, we want to solve the system of inequalities, and we have these two lines that are not in slope-intercept form. So the first thing I'm going to do is I'm going to convert it to slope-intercept form by solving for y. I'm going to subtract 2x to both sides. 3y is greater than minus 2x plus 6. And then divide both sides by 3. That gives me a y is greater than minus 2 over 3x plus 2. 6 over 3 is 2. We also want to graph this one here. And I'm going to subtract 8x to both sides. And I have 4y is greater than minus 8x plus 32. So from here, if I divide everything by a negative 4, I have y. And remember that when we divide by a negative on either side of an inequality, we have to flip the sign. And so we have a minus 8 over 4, which is a positive 2. And then 32 over negative 4 is a minus 8. So we have two inequalities that we have to graph. Okay, let's go ahead and graph this first one here. Start off at 2 on the y-axis and go down 2 and then over 3 to the right. Down 2 over 3 right. Down 2 over 3 right. That gives me good enough for my line. So what did I do wrong here? This is not an or equal to, so I need to show that it's just acting as a boundary marker. It's every point on this line is not true. From here, I have to figure out what side to shade on. I could plug into the inequality that I just graphed, or I could plug into the original. I like plugging into the original. I like using 0, 0. If I plug in 0, 0 into the original, I can see right off the bat that it's going to be false because 0 is not greater than 6. That's false. So that tells me I'm going to want to shade on top of my line there. Let's graph the other line in blue here. We have a negative 8 for our y-intercept, and we go up 2 and over 1 right, up 2 over 1 right, up 2 over 1 right. So we're going to go ahead and graph that line there. And once again, that is a line that's not or equal to, so we want to make sure that we have a dashed line. It's just a boundary marker. I'm going to go back to my original inequality and plug in 0, 0 to see if it's true or false. So let's plug in 0, 0, test point 0, 0. I can see right off the bat that it is going to be false. 0 is not greater than 32. That is false. And I want to shade on the opposite side. So where are they both true? This region right over here. The lines both overlap each other here. Right? So any point that we pick from that section is going to be true.